We're now going to create an instance of this part in the assembly container by double-clicking Instances, and we'll choose the fluid part. Click Apply and Cancel. And we're now going to apply some fluid boundary conditions. So we're going to define the inlet and the two outlets. And we do this by creating surfaces. So we'll double click Surface, we'll define a surface called Inlet, and this is a geometry surface. We'll choose the inlet, which is this surface, accept, and then we'll create two new surfaces called Outlet. We'll select these two surfaces, and then finally we'll define the wall surface. Make sure that we've selected everything and then accept. We will use these surfaces to define our fluid boundary conditions. So first we'll create our analysis step by double clicking on steps. We'll call the step CFD. Then in turbulence we're going to give it a turbulence model. And if we check the incrementation, the time increment we're using is 0.01 seconds, and the time period we're going to define as 0.2 seconds. Just check everything else. I'm going to increase the iteration limit, but you don't have to do this. This is just in case the analysis takes a long time to prevent the solver from exiting. So we click OK. We then go to boundary conditions, and then we'll define the inlet, and it's a fluid category, and it's fluid inlet outlet. Then down here we select surfaces, we select the inlet, and for the momentum we'll specify an inlet velocity in the positive z direction of 10 meters per second, and in the turbulence tab we'll set kinematic viscosity of 1 times 10 to the minus 5. We'll then create our outlet boundary condition, and then we'll choose outlet, and then we'll specify a pressure of 0. Then finally we make a wall boundary condition using fluid wall condition, and we choose the wall surface. The condition is no slip, and this effectively defines the velocity profile across the wall, across the section. So we'll have 0 velocity at the wall and maximum velocity at the centre of the pipe. We can define turbulence with a predefined field by double-clicking predefined fields, choosing the initial step, fluid turbulence, and then selecting the same value of 1 times 10 to the minus 5. And then finally, if everything has been set up properly, we can solve this fluid model and view the results in the visualization module. So if we double click Jobs, and we'll just accept and accept, and then right click Job, and then click Submit. Once the job is complete, we can right click on Job, Results, and we can view the result of the CFD analysis in the visualization module. We can use plot contours on deformed shape to look at the velocity at the inlet and the outlet of the pipe. What I like to do is increase the font of the legend here. So if we go to Viewport, Annotation Options, Legend, Set Font, and then set the font to something like 24, we can get a better look. We can also view this velocity contour as a series of symbols. So if we go to common options, feature edges, then we view wireframe and we plot symbols on deformed shape. We can see the velocity vector at the inlet and at the outlets, and we can see that the velocity at the inlet is approximately 10 meters per second, and then at each outlet the velocity is about 5 meters per second, since there are two outlets.